Oh no, I can say gato. Obrigado. The man at the hotel taught me to say I'm sorry last night, but I forgot how to say it. Excusa?
Desculpa.
Desculpa. Okay. Desculpa. Okay. So Breno gave me this talk title, and I had to figure out what to do with it. This is actually the way I like to do talks now, because I don't have time to think about something that I want to do, and the organizer needs to force it on me. So I now have to think about what is in my Perl bag of tricks. What do I do that's just interesting or helps me along? This isn't going to be some sort of wizardly black magic, super clever stuff. Some of it's just going to be things that I do that might be interesting. So as part of this, I went sort of looking around for things I might include that would sort of showcase Brazil. And here's, Pele, the most famous footballer in the entire world in all of history. And here's his trick. Look at how high he can jump. I cannot do that. So my tricks might not be as impressive as Pele. So I went looking for other sorts of impressive Brazilians, and I found this architect. You recognize this building?
Yeah.
I was very surprised when I saw this picture, because the cup there looks like it is sucking in the atmosphere, and that maybe all of you control everything that happens in the world by tricks. Again, my tricks will not be as impressive. But I also want to thank you, because you might remember that where I am from, in Chicago, we were trying to compete with you to get the Olympics, which would have meant I would have had to move away from Chicago if we got it. But you won, so no Olympics for Chicago. You guys can have all the world come to you.
Yay for us.
For 3 months. Although I hear that you can probably rent your apartments for several $1,000s a week and get very rich. Okay, so when I look through all of the stuff I have laying around in my home directory to see what I might want to show you as tricks, I try to think, why do I do these sort of things, and what sort of things should you learn from this? It's not just Perl syntax, because sometimes I'm using stupid syntax or something that I wouldn't put into a big program. But there's a few things that I try to do for the things I use over and over again. And one of them is to eliminate special cases. And this is one of the rules of programming. If you get to be a good programmer, what you want to do is not have some one item be treated specially, and then you have to treat all these other items together. You want to treat everything the same. And so some of the tricks I do sort of rearrange the problem a little bit so that you don't have a special case. That's really what programming is, if you think about it, is we're going to take a big problem and reduce it to problems we already know how to solve, and then use those solutions. Just like you do like little tile puzzles or the Rubik's Cube or something, you get it to a space where you know, oh, I know how to solve that, and then you're the rest of the way there. Have you guys heard about the joke about the engineer and the physicist and the mathematician trying to change a light bulb? So the light bulb is broken, and the physicist writes down some equations, the height of the room, and you need a ladder, and the ladder has to be at this angle, and he says, okay, I've solved it. But the light bulb is still broken. The engineer, he gets a ladder, it's not tall enough, so he gets a chair, and he puts it on top of the ladder, and he climbs up, and he changes the light bulb, and it is now fixed. The mathematician sees a light bulb, it's fixed, he breaks it, because he knows that that's a known problem. Yeah, I now know how to solve that problem. Okay, one of the other things, come back, that I want to do is remove distractions, things that are in the code that you don't really want to see there. So if you can get rid of excess code somehow, that would really help the program. You don't want to think about things you don't have to think about. And along with that, there's this idea of having to know less. The less you have to keep in your head, the easier your problem is. There's a lot of things that Perl can do for us that people don't know about. They're sort of hidden features, or they're not quite spoken about. For instance, if you look at the pack or the sprintf Perl doc entries, those are very, very long. How many people have ever read through the entire thing? Okay, see, very few people. There's really cool things in there. I get to learn about those because I have to write about them for the books. Then I have to find some way to use them so I can make an example. And then what you want to do is somehow write your code so that if you have to do more work, if you have to add more cases, you don't have to change the code around. You can just add the cases in there. So just think about those things as I show you these tricks. Now, some of the tricks aren't going to be all that fancy. I'm not clever. I'm not that great of a programmer, but I get by. So let's start with this one. Okay, so you might know about the -E switch. You can run a little script on the command line, but how many people know about -L? That will automatically put a new line on the end for you. So you don't. See here on the top one we have the double quotes around it because I'm trying to get used to that because that's what people on the Windows command line, the command.exe thing have to do. You can't use a single ticks there. But then I have to do the generalized quoting in the middle, and then I have to put the new line in there myself. I don't like that, so I can just do the one on the bottom. That one's very nice. I could have just filled this up with all sorts of command line switches, but I'm not going to do that. This is the only one that I'll show you. But there are a lot of things that can help you on the command line. If you haven't been a sysadmin or had to put these things in your login files or whatever, read through Perl run a few times, maybe more than a few times, to see what's available there. There's a lot of stuff you can do on the command line. Okay, if you were in my class yesterday, I apologize because you're going to hear this one again. This is one of my favorite things. Since Perl 5.6, you can open a file handle onto a string, or more correctly, a string reference, or a scalar reference. So instead of treating things as a string, I can just treat them as a file handle. Okay, I don't have to do special string sort of things because I can do file sorts of things. Now remember what I was saying before. This is eliminating a special case. This is removing a distraction. Everything now can just be a file handle. So I can write a subroutine or a method that takes a file handle, and I can just pass it a file handle to a string, and it can operate on that string just like it would a file handle. So that's one less thing I have to do. I've reduced it to a known set of problems. So this one I've opened for reading, but you can also open them for writing and all the other sorts of things you can do with file handles. That can be really nice. This is especially handy, by the way, when you want to test encoding sorts of things. If I output this as Latin 1, what does it show up as? Or if I output it as UTF-8, what does it show up as? You don't actually have to write it to a file because you can just write it to the string, and then you can just dump the string and see what the bytes actually are. Okay. This one is really nice. Again, if you were in my class yesterday, I apologize. I'm not really sorry, though. You're going to see this one again. Since 5.14, the substitution operator has a new flag, the /R flag. Now, before, the substitution operator would take its target and operate on the target, so your string would be different after the substitution. I mean, if your pattern matched. But the /R says, don't change the target, don't change $old. Take whatever the result would have been and give it back to me as a return value. This is instead of returning the number of substitutions it made, which is the normal return value for the substitution operator. So on the top, you can do it like that. Old is going to stay the same, but the result is going to be in $new now. But the curious thing, and the thing that I really like, is now you can do this like in a subroutine call, for instance, as an argument. I want to pass this thing that looks like $old, but has a slight modification, but I don't want to change my original data. You can do that directly in an expression. Or you can do it in this last, or that should be printf there. I don't have any special magic that makes that work like printf. That's not one of my tricks. You can say, I want to print out $old, but I also want to print out its change value. So you can do that directly without ever having to make a temporary variable or actually change $old there. I really like do. If I could put that in more places in my program, I probably would. So we have here a for each that is going to go through a bunch of files, and I might not be able to open one of them. Maybe I don't have permission, my disk is full, or whatever that is. As I said in my class yesterday, I can't necessarily stop my program just because I can't open a file. I can't use something like auto-dive. I don't really want to use an exception here. That's a bunch of extra code I don't need. If I can't open this file, I still need to process the other ones. But after the OR, I only get one expression there. Unless I put that in a do, which is a single expression, and then the stuff in the do block lets me do whatever I like. For instance, in this case, I can do the warn, and then I can say next file. I can't really call a subroutine there, because I can't use next from the subroutine. It has to be in the same block of code there. So this sort of works out. Now I know I could have turned it around, and I could have said if open, then a block, but then that stuff around the open is a distraction for me. I want the main thing, the open, to have the prominence there in that statement. So if I put that on the first line with nothing else around it, it's very clear that I'm opening a file here, not getting into this if stuff. The if stuff might happen somewhere. I don't want to look at that every time. So I shove that other stuff to the side. It's a style thing. I'm not recommending that you use it. I just tend to like to do that. That do lets me put a bunch of stuff as one expression. It's sort of like an inline subroutine. Oh, here's another one that I like, because I used to be a sort of a quick and dirty programmer. I still might be. You know about end. It stops your program, and then after that, there's a bunch of stuff. So a lot of times, instead of having a program file, I have a data file. And I just happen to put a program above the data. A lot of people think of that as putting data under the program. I'll download something from, in my web browser or whatever, open the file, and I'll just put the in there, and then type a quick program to process it on the top. There's a lot of stuff I do with Perl that I'm only ever going to use once. I get this XML file or I get this HTML file, I scrape it real quick to pull out, the movie times or the sports scores or whatever it is, and then I'm done. I'm not going to write a module for this, I'm going to move on to whatever the next thing is. And so I'll just take the one file, have it all there, and then I'll keep running it until I get the thing that I want. Not all the stuff has to be best practices. You're probably tired of best practices talks anyway. So I'll show you some not so best practices. Now here's another interesting one that's sort of like this, but it's a different trick. I'm going to do the same thing. I have my end there, and I have all the data after that. And I want to process it. So at the top, I'll just suck it all in at once. That's another instance of do there. And then everyone will tell you can't parse XML or HTML with regular expressions. Well, you can now in Perl because they're not regular expressions. We have grammars. But what I'll do is I'll just take these two substitutions and I'll look for everything up to where I want to start processing and just get rid of it. I'll take everything after where I want to stop processing and get rid of it. So now I've reduced the problem to this little chunk of stuff which is much more manageable. I've gotten rid of all the other things that I don't care about. And now my regular expression can be much simpler. Okay? So I only have that little bit that I have to deal with. So I removed all the other stuff. Now this is probably just going to be a program that lives for about 5 minutes. It'll probably sit in some file unused for the rest of my computer until I get a new one. But I'm not going to look at it again. So I don't care if this thing runs quickly or not. A lot of the stuff on any sort of modern computer will run faster than I can blink. Okay? Our eyes can see about a resolution of about 500 milliseconds. And so sometimes these programs seem to actually finish before I hit enter. These are how fast these things can run. The perception loops from my finger to my brain and from my eyes to my brain seem to get mixed up. So I don't care that these might be slow. I don't care that I'm taking up a bunch of data there. If that's 200 gigabytes, that doesn't really matter to me because I have a machine with a lot of RAM. So I'll just be sloppy, and then if it's freed up as soon as the program's done. Now here's another interesting one. You guys might have experienced this pain as well. We have this string. Here's the names of my cats. And if you were in my class yesterday, you saw a picture of Buster. He was the black and white one. But I also have Mimi, Buster, who we sometimes call Buster Bean, and Roscoe. Now look at this string. Now that's just a string. That's not a list. That's just a single string. The Mimi's quoted, the Buster Bean is quoted, and the Roscoe is quoted. But look inside the Buster Bean, there is a comma there. So if I want to break these up, I can't split them on commas because in the middle of one of these things is this comma. How many people have had to deal with this comma-separated values format. Like it comes out of like Excel or Microsoft, these sorts of things. They just like to put quotes around everything. Now what I could do is I could split on close quote, comma, open quote, but then what happens? I'm going to leave a quote on the front of the first element, and I'm going to leave a quote on the end of the last element. I've just created two special cases. So what I can do instead is I'll split on this. Now these look kind of scary if you haven't used them before, and I continually have to look these up to remind myself which order the characters go. But we have two capture groups there. Well, not really capture groups, but they're groups. They have a question mark at the beginning. That means they're one of Perl's special regular expression features. Now the first one has the less than. It's pointing back, down. So this is a look behind. This is, the fancy term for this is a zero width assertion. It's saying something about the position in the string, but not consuming any characters. So it's not matching characters, it's matching a condition. And the condition here, with the equal sign, is saying the thing that's right behind me has to be a double quote. So if that thing right behind me is a double quote, this positive look behind is true, which means that part's going to match. But it's not consuming that double quote. It's going to leave the double quote alone. It's a zero width assertion. Now the one after it, the one just question mark equals, is a positive look ahead. The thing after me has to be a double quote. Same rules as the thing before. So if I find a comma with a quote before it and a quote after it, I'm going to split on that comma. But it's going to leave the quotes alone. So the look aheads can be really handy. And once you get used to them, they are sort of weird, but once you get used to them, they can be pretty powerful. Now I'm going to show you an even fancier one. Now again, this top thing is just a string. We have the open quote, Roscoe, and then a double quote, a comma, a double quote, and then cat, and a close quote. Some of these formats, if they have a double quote inside the thing they're double quoting, just double up the double quotes. So now I can't do the same thing I was doing before. I can't look for a quote, comma, quote, because it might be something like this. Now, I've made that up and it looks kind of silly, but that's what fits on a slide. However, I can use more look-arounds, the general term for looking backwards or forwards, to solve this. So in the middle of this split, I have the same thing. I have the comma and I have the two positive ones, the ones with the equal signs. Now, on the outside of these, I have something that looks similar, but I'm using the bang instead of the equal sign. These are negative look-arounds. The thing before it can't be this. So the first one says question mark less than bang. So that is a negative look behind. I'm going to look behind and see if it's not two quotes. But I'm also going to look behind to see if it is a single quote. Now the only way that those two things can be satisfied is if there's only one quote there. Hopefully there's not like three quotes or something like that. That would be kind of weird. Okay, and then the same thing on the other side. I'll look forward for a single quote, but not two quotes next to each other. So now I can split that up. Okay. But the only character I'm actually matching is that comma.
Which comma will you match?
I will match the one just between the one that says cat, close quote, comma, open quote, bean. So if I could reach that far. Stop it. This will be the one that I'll match. Because it won't match this one because there's no quotes around it, because there has to be a quote around it. And it won't match this one because there are two double quotes around it. And I end up doing that quite a bit. I do a lot of text processing stuff, so split is really my friend. If I can get the right split pattern, things can be really easy. If not, then you have additional steps to clean up various things. And I want to get rid of special steps. Okay, this one I like. It's a little bit more typing. Now I've crossed out the one on the top. You might see something like this. I want to check to see if this thing's an array. So you say ref something equals array. And that's fine if you can remember what that string is, A-R-R-A-Y. Okay, now that one's easy because we're familiar with that one. It's all uppercase. But who knows what the string is for a regex object? Yeah, okay, so at least one person, right? I can never remember.
But I wrote the data printer thing, so I had to. And it bit me more than once.
Yeah.
The naming of the...
Yeah. So the trick with the regex one is that it's not all uppercase. And I can never remember if it has a P or it doesn't have a P. Does it have a P?
It doesn't.
It does not. You see, I keep putting it on there. I keep
But
putting
it's
regex.
UC first.
Yes. The first one is a capital R.
Yep.
So I shouldn't have to remember that sort of stuff.
Right.
Yes. Oh, no, I'm fine. But thank you. So what I'll do in the second line there is I'll say ref of an anonymous array constructor. That will give me whatever the magic string is. If they ever decide in Perl to change this, let's say like in Perl 518 or 520 or something, we get a new pumpkin who hates all capitals, my program will still be safe. Also, people who come around and know Perl but don't remember the special words will know what that's doing. I can do the same thing for a hash. There's the ref of the curly braces or a subroutine, or like the last one will give me the whatever the string is for the regular expression thing. And I'll never have to remember that again. I only have to remember one thing. Put the sort of object I want right after the ref, no matter what sort of object it is. So you can do a similar thing for classes too, but we won't talk about that one. Okay. Here's one of those that gets rid of special cases. I want to print out at entries, and I want to put new lines in between them all. But if you do that and you print it to your terminal, you get your prompt right after the last entry. So just stick a empty item after at entries. So taking a problem and sort of changing it around to be something else. I can do the same sort of thing in the second one. I want to put a tab in front of every entry. And I want each entry to be on its own line. So what I'll do is I'll join them on a new line in a tab, but I got to get that first one to have a tab in front of it too. I don't think this one actually, does this one work?
Just for the first one, right?
It'll be a tab, then a new line, then a tab. I could have put an empty string there, I think, and it would have worked out just fine. But again, switch it around, somehow make it so that the thing that you're doing looks like some other problem. Here's something interesting that you can do. I could talk for hours and hours about this little trick, and I think I have a whole chapter in Mastering Perl about it. I want to change package foo. This is some module that I'm using that they haven't fixed. It has bug reports, or I have a patch or something. What I don't want to do is change the original source. And I want to leave it as it is, just on CPAN and how I have it installed. So what I'll do in my program, until I get this fixed, I've already sent in my patch, I've done all my good CPAN author things, is I'll load the package to make sure I load everything it does. Then I'll say, I'm in package foo. Then I'll redefine the subroutine that has a problem. And I'll put in my fix. Now, I can also do stuff here to see if the one that I loaded was greater than the version that I made the patch in. So say I make a patch in 1.01, I send that off to the author, and I'm expecting him to release it as 1.02. If I check to see if it's 1.02 or greater, I can say, okay, I think he has my patch, so I don't have to do this stuff. But you can do this sort of thing in Perl. Perl's a dynamic language. You can redefine a lot of it on the fly. I do this quite a bit, because a lot of my work is fixing CPAN modules for people. Okay. I go into a company and they want to fix some things, but their employees are focused on their business stuff. There's stuff that they're writing that deals with whatever their domain is. They say, we just need this CPAN stuff fixed and we can handle all the other stuff. And I'll work on that part, and I can put that stuff in their form. When they're done, when they think that they have that working, they can just remove that begin block. Speaking of that, speaking of fixing things, if you haven't learned Git, it's the way of the world, and people will laugh at you if you don't use it. Yannick Champeau wrote this thing, Git CPAN patch. It provides a bunch of Git commands that will interact with CPAN. You can say git cpan init and give it a URL. It's going to download that tarball. It's going to unpack it. It's going to make a git archive out of it and check it out into master. You change around what you need to change. You commit it, and then you say cpan send patch. It takes your commit message. It makes a entry in RT, and you're done. Okay. Now imagine what you would have to do before this. You download the tarball yourself, you unpack it. If you're not using Git, you would somehow have to figure out, is it worth putting this thing in source control? You'd probably say no. You would make another directory, you would change this up in one directory, then you have to figure out, okay, now when I do diff, do I put the old first or the new first? And then you get some sort of patch out, and then you have to upload it yourself somehow. This does all of that for you. And the thing that's really nice about this is the Git stuff is so lightweight and so temporary, I don't know if that's a good word, that you don't care that you make this repository, do your one thing, and then throw it away. You don't have to set up anything, you don't have to get any sysadmin's permission, you don't have to do any of that stuff. This is very nice. I do this quite a bit. This is how I patch other people's CPAN modules if they're not already using GitHub, where I can just fork and send a pull request. Okay. You saw a lot of map yesterday if you were in my class. I didn't show you this trick though. A lot of people will use a map to go through and create a new list out of data, but I like to use map to go through lists of methods. Okay. So I'm just going to get some information about an MPEG file, and I want to print it all out. So I'm going to say join on the input record, or excuse me, the output record separator. No, I got the wrong thing there. As long as the input record separator is a new line, I'm fine. Then I'm going to say map, and I'm going to go through and leave file the same, but each time through the map, I'm going to change the method that I call. So when I need to call a bunch of methods on the same thing, instead of saying $file arrow method, $file arrow method, and keep doing that over and over again, I'll just use a map. Because I can take that method, which will be in $_, and call that directly on the object. I just say $_, but I have to put parentheses after it. That's how Perl figures out that I'm actually doing a method call. Again, sort of removing distractions, eliminating special cases. I only have to type $file there in the map once, and I can call as many methods as I like on it. How many people have heard of modulinos? This is one of the terms that I started using that actually stuck in Perl. Mostly because I got to write a chapter about it in one of my books. But Perl monks got very excited about it too. A modulino basically was, in Italian, the term would be a little module. The idea being that your script acts as both a module and the script itself. You have like a run subroutine, or you call it main, or whatever you like. Activate's popular too. And then you have this trick here: run with the argument list unless caller. Caller is going to return the information for the thing that called you. If you're loaded as a module, there's something that loaded you. If you're run as a script, you're the top level. There's nothing that called you. So if you're called by somebody, caller will be true, so don't do the run. If no one calls you, you must be a script, so go ahead and run. Now the great thing about this is that if you make this as a modular structure, you can do all that great testing stuff that you just heard about. You don't have to run your entire script to test it. Previously, if you had a program and you wanted to test it, you'd have to run the thing, give it some input, and hope that with all the stuff in the middle, the right answer came out. But now it's just all methods. So now you can test the methods individually because you can load it without running it. And then when you do want to run it as a script, it just does. Oh, this one got sort of cut off. And whenever I see this, I try to adjust my computer, but of course that doesn't work. Oh, I see what's... Just need just a little bit. There we go. We can have user-defined properties, Unicode properties in Perl now. So I can define this thing. I'm going to say is uppercase Roman. Now it has to start with is. That's how Perl knows that this subroutine is going to define a property for me. Okay. Then what I do is I put in the code point numbers for the Unicode characters that I want to be included in this property. This is like a fancy character class where I don't have to constantly put in all the characters I want in the character class. So I have the uppercase Roman numeral characters. If any of those characters match, I want that property to match. But I don't have to put all that stuff into my regular expression. I don't even have to type those characters, because I can just put the code numbers inside there. Now inside this little string, it's line-oriented. If I only have one number on the line, it means just that one character. If I have two numbers on the line, it means from the start character to the end character. And I can separate those by white space. Okay. So now I've given a name to all these things, and so I don't have to be distracted in my regular expression by trying to figure out what all that stuff is. I just say what it is. It is uppercase Roman. I'm starting to like this a lot more for doing things. It's like defining your own character classes. Okay, now printf is one of those things that has its own language. You'd be surprised how many languages you actually have to learn to use Perl. You have to learn Perl. Regular expressions are its own language. We have pack, and we have printf. And there might be another one. I'm not sure. No, I don't think there is. But we could do a lot here if we know the formats. Now what I'm going to do is take this number 137 and print it out in binary, octal, decimal, and hexadecimal. Now I could just do it each time. I could have 137, 137, 137, 137 for each of those formats. But then I have to repeat myself. Maybe I mistype it once and I have 139 instead of 137 or something like that. So what I'm going to do is I'm just going to type it once. Now you see in the purple there, or magenta, I have these $1, $1, $1, $1. You can tell the printf format which argument to use. You give it its position, which is the 1, and you put a $1 after it. This is not a variable. This has nothing to do with Perl syntax. This is its own little language. So now I just say everyone use the same argument. Now you can do this for as many arguments as you like, so you can take the arguments out of order, you can reuse them, you can ignore some of them, and so on. Now also notice that I have the hash marks before the B, the O, and the X. When I put those in front of any of those, it automatically adds the 0B or the 0 or the 0X in front of those number formats. So I don't have to stick that stuff in there either. This is the sort of stuff that you pick up when you read all the way to the end of the sprintf man page, which is something like, I forget, 600 or 500 lines long. In the new programming Perl, which should come out in January or December, I think it's about a third of a chapter, just this one thing. Okay. Oh, this one actually has Portuguese on it. Good. I like this trick. So we're going to call this subroutine gato. Am I saying that right? Okay, good. And that's my cat's name, Buster. And I'm going to have some defaults. I'm not going to tell you what those are. It'll just fodder up the slide. If I don't specify something, it'll be in that defaults hash. And then what I'll do is I'll say my config is going to be %default and then whatever my argument list is. So anything I don't specify picks up the version from defaults. Anything I do specify overwrites the thing for defaults. Now this is for quick and dirty programming where I don't really care about this sort of stuff. I mean, there's all sorts of fancy things you can do with Moose and params validate and other really fancy modules if you wanted to. But if I'm writing a little script where I need this sort of stuff, I don't feel bad about doing this at all. Oh, this one I like for testing. You can actually redefine what some of the things in Perl actually do. Now suppose I have this thing where I need to test what it does with a certain time value. Somewhere deep inside this module or somebody else's module, it's going to call time. Now I want that time to come out as a specific value so I can see what happens. So what I'll do is I'll override it by defining core global time. Now I keep having to look this up, even in my own book, because I can't remember if it's core global or global core, even though I know the rule is core is always first. But I do this, and I'm just assigning to a type glove there a subroutine, and now I can change that. Notice here, I have my fixed time defined at the start of the begin block, but I also have this other little closure, set time, where I can pass that an argument to change the time. So then later in my test, I can do something like this. OK, time greater than whatever I set that as. Or whatever I need to change that to so I get the desired behavior. For instance, if you want to make sure that a test or a function doesn't see a file that might exist, you can override the file test operator so it always returns false. So it looks like the file doesn't exist. You can see what happens without having to make up some weird situation by moving files around and making directories and all sorts of things to see that. I often like overriding open. Make open fail without having to do lots of tricks with temporary files and directories and all that sort of stuff. So make it always fail. Core global is a place where you can do that. Now, if you ever wanted to get back to the original version of these, you can call core, then whatever the built-in is, like core time, without the global in it. You'll get the original, so you can actually use that inside your overridden one. Okay, oh, I like this. I actually stole this from one of my modules called Object Iterate. You can write your own things that look like grep. There's a prototype there that has an ampersand character as the first thing. Now, it always has to be the first thing if you're going to use the ampersand. So that lets you use the first argument as a block of code, and then you can make it look like map or grep. We have a block of code, then no comma, and then the rest of your arguments. Okay, and then inside it, you'll just get the subroutine as the first thing on the argument list, whatever that is. And then you can go through each of the arguments and do what you have to do. In this case, I'll set $_ to be a local variable, and I'll put the thing I'm going to process on there. So inside the block of code, just like map and grep, the current argument that you're processing is $_. You could do fancy things with $A and $B too, if you wanted to make it look like sort or reduce. This one was in my class yesterday too, so you'll get to see this one again. I like to do this sort of stuff. Take some subroutine and takes a bunch of subroutine references and wraps it all into one tiny little package. So you don't have to keep doing the same thing over and over and over again. And here's how you would do that. Take a bunch of references, make a new subroutine in it, that references that list of subroutines. So this is a closure. And then just go through each subroutine ref and do your thing. So these are little pipelines. You can define little workflows that you can call as a single subroutine. So your little workflow here to do the trim stuff off the front, trim stuff off the back, and do a UC first, now has this name, UC first and trim. And with this composer subroutine, you can write as many of these little workflows as you like, give them whatever name you like, and use them for as long as you like, without having to go through and call each of these name things over and over again. And if you decided the workflow should be different, you have one place to change the code. You just change the little pipeline that you use. Okay. When you get big into testing, and hopefully you do, because this is the best way to learn how to program, is to find out how to break things. Trying to get complete coverage of any sort of module is going to teach you a lot about programming. Because you're going to say, I can't test this thing because of this weird way I structured this. And then you find out, if I just write the code like this, it's easier to test. And then the code's a lot easier too. So inside a lot of my tests, I've started doing this, because now you start thinking about how can I make this test easier. I want to go through a bunch of things, give it some arguments, see if I got the expected value, and give that a label, because all tests should have labels. I think you saw one of those in the TDD talk. There was a test, unique labels or something like that. I forget what the actual name is. Mine typically don't have unique labels, so I don't use that one. Now this is called, you can call this table-driven testing if you like. So it'd be TDT. We should come up with a bunch of really hard acronyms and use those for our things. Things that the letters just don't belong next to each other. And so up at tests, I have a bunch of anonymous arrays, which are each one little test. Now you don't have to do it exactly like this. You could use hashes or some other data structure. It doesn't matter. The trick is all my use cases are in at tests, and this for each doesn't know how many things it's going to get, what's different about them, or anything else. It just goes through each of the little anonymous arrays, uses the arguments, looks to see if it's a thing that it expected, and so on. Now I have some, normally I'd have constants in here for this, like arg, expected label. It doesn't fit on the slide. So you don't have to remember which position it is in the array. You just know that the arg is, whatever that constant is. So it would be like position 0, and so on. Okay. Then when you want to add another test, you just have to add another entry to this table. You don't have to copy and paste a block of code and have another test there. Oh, this one is a lot of fun. At some point, I want to write a nice little book about real object-oriented programming. The stuff that we have about exceptions and all this other junk that people got distracted by really misses the point. And this isn't even the good one yet. I have a lot of this sort of code in my things I write for other people. I have this init logger subroutine. I'm going to try to load log for Perl. However, if it's not there, I don't want to have to go through and do something special for all those logger calls I'm going to make. And I want to leave all that log for Perl stuff right in the code so that when they do install log for Perl, they'll get it for free. So what I'll do instead is if I can't load it, I'm going to return this object from local no logger, which is this little package I've defined at the top here. It has a new subroutine that just makes a placeholder object. It has an auto load that just takes whatever you give it, takes off the class name, that's the shift, and then just prints out whatever message there was. That's all it does. This is for any method that you call on that object. So warn, debug, fatal, whatever you, foo, any object that you make up. And you can get a little bit more fancy with that, but what's the point? If you're going to make the null logger more fancy, just install log for Perl. But this will make this work even if that module is not there. It just won't do anything. And if you don't want it to even print, you just make autoload do nothing. So it'll call the method, nothing will happen, and then the program will continue. Or maybe you want to make it really annoying. You put a warning message in there that says, install log for Perl, you idiot. Okay. Getting even more fancy than that is this guy. Some people like to write things like this. They'll say $object, arrow foo, arrow bar, arrow baz, arrow hooks. This is a chain method call. So you're calling a method on a method on a method on a method. But what happens if one of the methods in the middle has a problem? Okay. Well, if it returns undef, you're not going to be able to call the next method on it. You're going to get this weird thing that says can't call whatever it is on undefined value at line so-and-so. Now, a lot of people will handle this with exceptions. They'll just wrap eval around it. Okay, that's no good, though. I don't like how that flow control goes. All of a sudden, you're passing stuff up and making it somebody else's problem. So what I like to do is this sort of thing. I'm going to make, let's say that object is a member of class there. And in bar, I'm just going to say return null new if we have some sort of error. There's some other code around that that is doing useful stuff. In my null class, all I'm going to do is make the singleton object. So I say my null is going to be this thing. It's going to use the same object for everybody. New will always return that same thing, null. And then autoload just always returns the object. So you always are returning an object, no matter what's going on. So bar returns the null object. So the null object has baz called upon it. The autoload picks that up, returns the object again. And then that null object has hooks called upon it. And then the autoload picks that up and calls it again. Now this is a little bit a lot simplified. But there's a lot of stuff that you can actually do in here. You can change this around from this simple case to where bar will actually give the null object a message to carry forward. Now, instead of having this object here, we make a new one every time. To carry forward that message, I failed in bar with this error message or whatever it is, you're just going to eat up the rest of the methods. Just going to keep going. You're not going to have to do an eval because there's no exception to catch here. The return value from this, the thing that you'll get back and you can assign, will be this null object that has stored in it an error message. And just like you could with functional programming, you check the return value instead of doing exception handling. Exception handling is ugly because you have to write a lot of code around the code that you care about. In this way, you're doing it just like you would with functional programming. I love doing this sort of stuff. I just wish I had more time to write sort of things about this. Okay, so I think that was the last trick. This stuff is on SlideShare, although it got cut off a little bit. I think it's already in my Twitter feed. So you can see this stuff again, and you can see these tricks. Thank you very much for taking the Olympics away from us. Thank you very much for having me. I love coming down to Rio. I have a visa that's good for 9 more years, so I'd love to come back. Are there any questions?
Yeah, that's a good question. How to get a visa?
How to get a visa?
Yeah, for 10 years. That's what I want to know.
Oh, I just went to our consulate. That's what they gave me.
No, that's not that easy, unfortunately.
Oh, okay. Where are you coming from? You need a visa.
Poland.
Oh, I see. This is between like the U.S. and
Brazil.
it might be
Yeah.
different for different countries.
Okay, so.
Well, okay, here's the real answer. Is I paid $140.
It's good the same in Poland, don't worry.
Okay.
But, there is more problems and.
Okay, so I can't help you because I've never had a visa to Poland.
I have a question. I saw that you use a lot of examples of loads, but what do you think about auto loads? Because I have some
Fear.
yes about auto load. I tried to don't use it as default, but I saw that you use in a lot of examples.
Yeah. Well, okay. So he's asking me what I think about autoload, and I think about autoload the same way I think about a lot of other Perl features. In that I wouldn't have necessarily designed the language this way myself. Not saying that I would do a better job than Larry did, but if I have to, I'll use the features that are there. And autoload is one of those things where I use it if I can't think of any other way to get the job done. It's messy. There's a lot that you have to pay attention to. In these two examples, there's not a lot that you have to pay attention to. Other uses of autoload, for instance, if you're going to handle a method through autoload, most people will forget that they have to now overload can to do the right thing, to say, yes, I'm going to handle this method. They'll just completely leave that off somehow. Or some of the other things that they would want to do. This is one of the features I think that looks easy to the beginner, but then there's lots of subtleties to it, so you have to be careful. However, as someone who writes about Perl, those are the most interesting things to think about. The ones where there's all sorts of subtleties and you can spend all day exploring them. Damien Conway once said to me at one of these conferences that both of us as writers have the privilege of choosing our problems. So your experience, if you're having to sit at your desk and get things done, and you don't get to choose your problems, might be a lot different than mine. Autoload is like the camel. It's ugly and sometimes it spits at you, but it can also walk 200 miles across the desert without a drink of water. So does that answer your question?
Yes.
Okay. Yes.
About the example with the regular expression in the Roman numerals, that's. I wanted to know why that's a subroutine instead of just defining a variable.
Oh, okay. So the question is, why does it say subroutine instead of defining a variable? Basically, it's because how they designed it. If we make a subroutine in a package that has is and then some name to it, it is automatically going to pick it up as being the Unicode property definition because it's a subroutine. So Perl then calls a subroutine, gets the string back, and then uses that. There's that, since it's a subroutine, that we can actually run code and make the property dynamic.
Yeah.
But I mean, the real answer is because that's how they made it. I mean, there are probably other ways to get the same thing, but this is what they did.
Okay.
Must have is at the beginning.
Yes, it has to have is, like capital I, lowercase s. So if you have other subroutines that have that name, you might accidentally have defined Unicode properties.
What about functional programming, please? In a Perl conference, because most of the tips I saw like functional programming tips. Like
Yes. So he's asking about doing functional programming in Perl. The interesting thing about that is, once you sort of realize that Perl is a lot like Lisp, in that you're moving around lists and composing functions like Where did I have that? Oh, I had it later. This is a very functional programming sort of thing to do. That you can get a lot of power out of Perl. If you're interested in this sort of thing, the book you want to read is Higher Order Perl by Mark Jason Dominus. He starts off the book by saying that Peter Norvig outlined, I think it was 7 or 8 things that characterize Lisp. It does this sort of thing, it does this sort of thing, it does this sort of thing. And when he started thinking about it in relationship to Perl, he realized that Perl did 6 of them. Okay? And, as opposed to other languages that might not even come close to that. So you can do almost complete functional programming in Perl if you wanted to. You can do procedural programming, you can do object-oriented programming, now you can do functional programming. You can't do logic programming, really. I mean, you can fake it by writing a module like AI Prolog or something. But my Perl got a lot more powerful when I started learning and understanding how to do this sort of stuff. Because now you're using the power of these dynamic subroutines to do a lot of stuff that just would have taken so much more time and typing to do previously. I would encourage anyone who's been using Perl for a little while and is used to it and think they're at a comfortable level to then try Mark Jason's book and just see some of the really powerful things that he does.
The book is free.
Yes, the book is free. I keep forgetting to say that. The book is free on his website, so if you just search for Higher Order Perl, and there's one by Mark Jason, and there's another one that's on Amazon that some guy's like stealing his book to reprint it or something. Just go to his website. It's like plover.com or something, like plover like the bird.
Yeah. Perl.plover.com.
Yes, and you'll find it somewhere, and Google should find it as well. Well, I think we're going to get kicked out of the room now. So thank you very much for coming. I hope to see you at dinner or whatever we're doing tonight, and then I'll be around tomorrow too.
Okay.
Okay.